Math Analyzers. Welcome to your Chapter 10 Lesson 4 notes, all about vertical shifts in our sinusoidal graphs, meaning now we're going to move our sine and cosine functions up and down as well. So, of course, if we're dealing with the general equation form, the general function form of a sine function, we've got A as the amplitude. The absolute value of A is the amplitude. And whatever the sign with the A is just where you start, if you start going up or start going down, right, first. The period is, of course, 2 pi divided by B. And that just gives us, how many times we have the entire cycle between 0 and 2 pi. And then the phase shift is that last thing that we haven't talked about yet, but we'll get there. The vertical shift is that up and down at the end of the function. So if I'm adding to the end, I'm moving up that many. If I'm subtracting from the end, I'm moving down that many. And that also gives us the value of our midline. So this will help us by giving us the midline. Okay. That'll help us by giving us the midline. And remember, then that amplitude is figured from the midline, how much up and how much down from that midline we are. So this is pretty nice. All right, it's not bad as far as things go, right? I kind of did you like a not bad one for the amplitude. Then we went into that whole period and frequency thing that is, for cyclical functions like sine and cosine. And now we're going back to something that's pretty easy to do, moving up and down. And then we'll do that last one together too. That's not quite as easy, but we'll get there, right? That phase shift, okay? Please note that, again, whatever that number is at the end of that function, that this is just like when you move your parabolas and your exponential functions and your absolute value functions. If you've got something being added or subtracted at the end, it's exactly what you think is going to happen. If there's a -1 at the end, you're moving down 1. If there's a +4 at the end, you're moving up 4. The whole graph moves up 4. And what just happens to be the case with sinusoidal functions is that there's this midline, this line, this horizontal line that's cutting that graph in half. And that is also determined by whether we're moving this up or down. So that goes right along with the value. The midline gives us that value at the end of the function, okay? So if I'm taking y equals sine of theta, here's that classic y equals sine of theta that we know, and I subtract 4 from the end and call it y equals, theta or x, right? Our variable is right here. Y equals sine of x minus 4. Well, now it just shifts us down 4 for all of those major points. So my start point is usually 0, 0. Well, let's head down to 0, -4, and then start from there. The amplitude hasn't changed. The period hasn't changed. The frequency hasn't changed. Just the fact that I've moved this whole thing down. So I still have an amplitude of 1, right? This is still an amplitude of 1 because the distance between my max and my midline is still 1, okay? So if I look here, now it's just that my midline has shifted down to y equals -4, okay? So that maximum is just only going to be up to -3, and then that minimum, being our a value of 1, is just going to be down to -5, okay? So you're counting up or down 1 to get back to that midline. That's the amplitude, okay? Which direction we're counting to get back to the midline. So it's kind of nice. This determines our midline for us. And then we can use that amplitude from there, and then we can use our period and frequency from that point, right? And how many are we fitting on the graph? So it's just one more piece that we're placing together with the rest of the pieces. So here are some examples, okay? Red function, your classic cosine function, as you know, starting up, heading down, coming back, right? There's one cycle, so our frequency is 1 because we get one cycle in between 0 and 2 pi. If I take that cosine function and I move it up 5, go ahead and count up 1, 2, 3, 4, 5. Boom, there we are with our cosine function all being moved up 5. Our midline is y equals 5, right? Or we move it down 5. Sorry, I want to be right there. Or we move it down 5. So all these classic points go down 1, 2, 3, 4, 5, and get back down here. And then that midline is y equals -5, right? So whatever the end number is, that's telling you y equals that for the midline. And then you use the amplitude to get your peaks and valleys from there. Use the frequency to get your how many cycles are in here, right? Okay. So the graph below shows y equals sine of x in the blue. All right. What's the equation of the red function graphed? Well, actually, there is, in this particular one, no change in midline, is there? Because this is your classic, this blue curve is your classic sine function. Sine x or sine theta, either one. The red function is where the changes occur. So how many sine functions are going to fit between 0 and 2 pi or 360, right? Well, you got one full one, and then you're going to end up fitting another full one. You can see it there, right? So your frequency here is going to be 2. Okay, your frequency is 2, which means your period p-value is 2, right? And the period is figured out by taking 2 pi and dividing by b. So if you know that your b value is going to be 2 because you're going to have 2 of these cycles fit, then those cancel out. You've got pi. Or in our case, since they have it labeled in degrees, nice and conveniently for us, right? Then it's 180. So you fit one full cycle between 0 and 180 of your sine function, right? So this is where pi is in radians. Okay, so we'd fit a second full cycle. That's why there's a frequency of 2. That's why there's a b value of 2 there. So that's that inverse relationship beating us again, right? But also our amplitude. Look at the peak here. The peak is up 1. The peak for this entire graph is all the way up to 4. So we also know that our amplitude value is going to be 4. So if we put all those together into the sine equation, the sine function equation, we've got y equals 4 sine 2, right? Because that's b. Yep. X. And no plus or minus at the end, because we did not raise our midline up or down at all. We did not do that. We did not raise that midline, which means we didn't move the graph up or down at all. All right, so it takes us a sec. Put all those pieces together, plug them into the equation. And again, it was helpful to know in advance that we had sine of x, right, as our start, so we could see what were all those changes. We see that we didn't move it up or down yet. So kind of a review of what pieces we've used so far. Now down here, new piece. And I can tell it's that new piece because if I really look here, the x-axis or y equals 0, that's not my midline. So when that's not my midline, I really do have to look, what are my max and min? So my max here, as we can see in all of these labeled points, my max is 9. And then we can see in these labeled points that my min is -5. Okay, so we can see our max and our min there. Let's kind of consider, are we starting up or are we starting in the middle of this? It looks like we're starting up, which would be cosine, right? So we also know that this is going to be a cosine graph based on our start. Okay, we've definitely got an amplitude thing happening here. So let's do some counting right? So from 9 to -5, right? Let's consider from 9 to -5. So 9 minus -5 gives me 14. And I need to get halfway between 14. So what's that? 7. So let's do some quick counting down, right? Down. 1, 2, 3, 4, 5, 6, 7. Okay, round here. Let's do some counting up from here. 1, 2, 3, 4, 5, 6, 7. Right straight across here is going to be that midline. It means that that graph has moved up to y equals 2 being that midline when we came in together. And actually, all you really have to do with that is what's 9 minus 7? 2. Okay? What's -5 plus 7? 2. That's how we get there from our max and our min. Counting up, that's why we add for the minimum. Counting down, that's why we subtract for the maximum. So what's that distance from here to here? It's 7. So there's my amplitude value. All right. Now, from 0 to 2 pi, how many cosine cycles fit? What's our frequency? We got one full cosine cycle from here to here. So that tells me that my b is 1. So I actually technically do not have to add my b, although it's good to know. And 2 pi divided by 1 is still 2 pi, which is why one full cycle, right? My frequency is 1. One full cycle fits between 0 and 2 pi. How do I know that? My x values. My x values give me what are my degree points throughout my graph. And so now I can put all of these pieces kind of together. This time, my midline is going to mean I'm adding at the very end, right? So y equals amplitude 7. Cosine, you can use x or theta. I'm going to use theta because that's my preference. 7 cosine of theta, and then plus 2 at the end. So the reason I put cosine of theta in parentheses was just to be clear that there is no frequency in there and that we're adding 2 at the very end. That isn't something that is necessary. I'm just trying to clear up confusion when it comes to that, okay? So just putting some pieces together here, just putting these pieces together as to how we're moving our graphs. And here's the big kahuna, the one we have to do ourselves. So we're going to graph y equals 2 sine 2x minus 1. And again, the reason I've put this in parentheses, not fully necessary for this specific problem, but more to be very clear that that minus 1 is at the end. And just because today that's my point is that minus 1, my d value is -1, right? That number being added or subtracted at the end is my midline. So my midline is down at y equals -1. So right down here, I know this guy right here. That's going to be my midline. My amplitude is 2. So since my amplitude is 2, I'm going to end up being up 2 from there and down 2 from there. But I have to remember that this is going to tell me how many sine functions I fit between 0 and 2 pi. Okay, so since my b value is 2, I take 2 pi and divide by 2. And since those 2's cancel, that means that my period is only pi. 0 to pi, I've got to fit one full sine function. Okay? And it's got to be up 2 from here. So I can actually kind of start down here. This is my midline. Sine's midline, middle points are here, 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 right? And I've got to fit a full sine curve between these that goes in the middle of this all the way up to 2 and all the way down to 2, I meant to say. I'm so sorry. And I kind of like lingered on that. And then this is meaning down to -3 up to +1 all the way, your max and your min. Okay, from that y equals -1 right here in the middle. And now I have to do that again because I have to fit 2 full sine curves between 0 and 2 pi. So let's head that again. So that would mean that here and here are my midpoints. So on my midline, and then up 2 in the middle of that, down 2 in the middle of that. Now we can connect. And again, remember this is a curve. So do some curving as you're connecting and getting 2 full sine curves in there. That's all the pieces. That's all the pieces together. All the things I explained through this are all written out here. And actually, it looks like the exact order that I did them in. Oh, nope. Here I did amplitude before I did vertical shift. Sorry. I do pick the easy ones first, the amplitude and the vertical shift. To me, those are the easiest 2 pieces to do. And then that period and frequency, remember the frequency is 2. That's the B value itself. I fit 2 sine curves between 0 and 2 pi. The frequency being B, the period is where does 1 sine curve starting at 0 end? And that would be pi. So there's 1, that's your period from 0 to pi. Okay, trying to clear that particular thing up because I know the way that I say that can be difficult at times, right? Okay. And certainly last but not least, now a fully blank, nice little graph for us to do. And this one's cosine. Okay, so let's take a peek. This is cosine. That's one thing to remember. Remember, the cosine curve is more like a cup, like that. So just kind of keep that in mind. Your A is 2. All right, so we're going up 2 and down 2 from the midline. Our D is 1, which means our midline is y equals 1. Let's get that sucker on there right now. Midline is y equals 1. I wrote it right here. Y equals 1. Okay, so what that's going to mean for us, so let's think about this. Cosine starts high, so we don't start at the midline. We start 2 higher from the midline. So that means I'm going to start up here at 3 as a max, and I'm going to head down 2 from the midline for the middle. All right, so let's call this the middle for now because I haven't done my period and frequency yet, but that will end up being down 2, which heads me down to -1 as my minimum. Okay, so those will be my max and min y values. Now the B value is 2, which means the frequency is 2, which means 2 full sine curves, cosine curves, will fit between 0 and 2 pi. To figure out the period, remember it's 2 pi divided by your B value, which means it's pi. So from 0 to pi, we're going to get 1 full sine curve, cosine curve in. It starts at max, ends at max, middle down to min, which means that midpoints are midway like this. And there is your cosine curve. There's 1. We need to get 2 because our frequency is 2. So let's get another full one on here. Remember, here's our midpoints. So our midpoints are here and here. Our minimum is way down in the middle, and our maxes are start and finish. So for cosine, remember it's a curve. Oh, down here, excuse me, I went down a little, missed one. There we go. Down there and back up, because it's 2 is our amplitude. So just to do a count, right? Here's our midline, 1, 2, down, 1, 2, up, 1, 2, up. There's our midline at y equals 1, which of course is from this right here, from 0 to 2 pi. That's where we're looking at, okay? And again, points, so we're starting at 0, 3. Main points, we've got pi over 2 down to -1, right? Here in this middle, you could call this pi over 4 at our midline, 1. Okay, then back to 3 pi over 4 and back to the midline. And then we've got pi all the way up to 3. And then we do that cycle one more time. So these are just some main points to get us going so we can see, okay, that y value gives us our max and our min. Okay, and we can see that we have fit one full cycle between 0 and pi. One full cycle of cosine has occurred between 0 and pi for those. All righty, guys. Now we're just adding the vertical shift, so the up and down movement. So just watch which of your sinusoidal functions you've got as you're doing that vertical shift up and down. But it's nice because that's just going to give you the equation of the midline. So after you know the equation of the midline, you can count up and down with your amplitude to get your max and your min y values. So it's kind of nice. Gives us a really nice little addition to what we're looking at for our full function. And boy, oh boy, last but certainly not least, I'll add those horizontal shifts or phase shifts. So once we do that, all bets are off. All right, guys, this has been your Chapter 10 Lesson 4 notes. I will be seeing you very soon. Have a lovely rest of your day.